In today's society, popular nanotechnology products and smart materials not only defy the laws of physics, but completely ignore some of them as well. How can that be possible when the laws of physics make up the foundation of every single thing in our world? Hello everyone, welcome to our channel. But this in fact is possible. Very much so. There are various kinds of smart materials, and we will be talking about a couple of them in this video. Sound interesting? Then let's skip the talk and get started immediately. Polymer Terminator. This material was named after the movie Terminator for its unique self-repairing abilities. Even if you cut this polymer in half with a knife, it will return to its original form by itself after a couple of hours. This doesn't mean that the broken off pieces will move on their own to automatically connect with their other half. But if you put the two pieces together and wait for a while, it will return to its original form as if it had never been cut. In addition, researchers have developed a plastic that can self-repair after being damaged. 97% of the time, this plastic was successfully able to repair itself. That is to say, that in 97% of the cases, the plastic atoms were able to restore their broken bonds. This is possible since the aromatic compounds in this polymer go through specific reactions at room temperature. Gallium. This material has already been introduced in our channel before. Gallium is one of the 4 metals that takes a liquid form at room temperature. The other 3 are mercury, rubidium, and cesium, and they are all commonly used substances in thermometers. Gallium is a beautiful, soft, and silvery material that melts at a temperature of only 29 degrees Celsius. This means that if you try to pick up gallium, it will immediately begin to melt in your hand. The boiling point of gallium is 2229 degrees. The melting and boiling point for mercury does not have a huge difference. Its boiling point is actually 356 degrees. However, unlike mercury, gallium can be handled without causing physical harm to the human body. For that reason, it is often used in place of mercury for clinical thermometers. In addition, when you combine gallium with other metals to apply to glass, you will end up with an extremely bright mirror. Basically, this metal shows us that even the most common element on the periodic table can have very unusual properties. Vantablack. Have you ever noticed that there are many different types of blacks? Some black colors are darker than others. Blackness is determined by how much light an object absorbs, as well as how much it reflects. And the more light that an object absorbs, the darker it will appear. Fun fact, scientists believe that the black hole is the one thing in the universe that doesn't even reflect 1% of light. Of course, it's not possible for humans to see the black hole up close, but thanks to Vantablack, we can imagine just how dark it would appear. Vantablack reflects almost no amount of light. This color of black is completely different from the normal black that we are familiar with. Its material is made up of vertically aligned carbon nanotubes and can absorb 99.96% of light. Fun fact, Vantablack 2.0 has been released recently. Basically, since this material absorbs an extreme amount of light, it appears extremely dark. Linex. What do smart materials and tin cans have in common? Let me answer that. Scientists have invented a material called Linex. It's a coating that dramatically increases an object's strength when it's applied. This material undergoes a chemical reaction and creates a long polymer chain that bonds to the surface of an object to create strength and flexibility. Linex is often used on plastic car parts to prevent them from cracking, but it can also be used on other objects to prevent them from cracking or breaking and as protection against hard impact. The ability of this coating to give fragile objects incredible durability is evident in this video. For example, coat these plastic cups with Linex. Immediately, this cup has the ability to withstand the weight of a single person. If you coat an egg with Linex, it will not break, even after dropping it from a high location. The applications of Linex are truly limitless. It can be used in any situation where an object needs protection from breakage or cracking. Supercooled rubidium atom, negative mass. Next, let's talk about a substance that truly violates the laws of physics. Specifically, it violates Isaac Newton's second law of motion, in which a force is equal to the mass of an object multiplied by its acceleration, or F equals ma. The law basically means that an object will accelerate in the direction that you push it. For example, if you push on a door, it will open forwards and never backwards. The substance that violates Newton's law was made by cooling rubidium atoms to as close to absolute zero as possible. This substance acts as a negative mass, so it will accelerate in the opposite direction that it was pushed in. Hydrogels. Hydrogels are substances with mechanical properties that behave like liquids. This means that they can be poured into containers and absorb water, yet still maintain a defined physical structure. Hydrogels are mainly applied in the medical field. They are injected into wounds, so they can be used as targeted drug delivery systems. Hydrogels are made from a network of long polymers. Recently, a DNA-derived hydrogel has even been created. They can be used for drug delivery to areas where cancerous tumors have been removed, yet cancer cells still remain in the tissue. In those cases, hydrogels are able to fill cavities and take shape so that successful deliveries of drugs at tumor sites can be achieved. Starlight. Out of all the materials we've introduced today, Starlight is the most mysterious. It was created not by a famous scientist, but by an amateur chemist named Maurice Ward, who was also a British forklift driver and hairdresser. He claimed to have invented a wonderful material that could protect any object from high temperatures. Indeed, several experiments proved that this material could withstand heat of up to 10,000 degrees Celsius. After Ward made this material at home and used it in his beauty salon for a while, he realized that it could be applied in other areas. So, he wrote letters to several major chemical companies to advertise his product. Finally, in the 1970s, he was invited to appear on the BBC channel's science programme called World of the Future, where he heated an egg wrapped in Starlight at 1,500 degrees for 5 minutes. After 5 minutes, he cracked the egg open to show that it was still raw. Ward succeeded in attracting attention to his invention, and even a NASA spokesman confirmed that this material was not fake. The spokesman claimed that, after careful experimentation, we now know that this material gives our future infinite opportunities. Basically, Ward obtained the public recognition that scientists all over the world work many years to earn. Starlight could be useful in a wide range of fields because it is heat resistant enough to protect against nuclear explosions. Well, it was supposed to be able to do that, if Ward had successfully transferred over the rights to this material. However, for some reason, he never agreed to let other companies have the rights to it. In 2011, the inventor passed away, and to this day, no one knows the fate of his invention. That's all for now, ladies and gentlemen. Thank you all for watching until the end. Perhaps in the near future, we will make another video on similar material that we were unable to introduce this time. We hope you enjoyed it. Have a great day, everyone. See you next time. Bye!